Ground fault protection is required for grounded Wi services rated 1000 amps or more due to several critical reasons. Firstly, high line-to-ground fault currents are a primary concern. Grounded Wi systems generally exhibit lower line-to-ground fault currents compared to Delta systems. However, when dealing with high amperage services, specifically those that are exceeding 1000 amps, these fault currents can still reach substantial levels, posing significant risks. Secondly, protection of equipment and personnel is crucial. High ground fault currents can inflict damage on equipment connected to the electrical system. This includes motors, transformers, and wiring. Moreover, these currents can create dangerous shock hazards for personnel who may come into contact with faulty equipment or wiring. Thirdly, system stability is a factor. Sustained ground faults in high current systems can disrupt the stability of the system voltage. This disruption can manifest as voltage dips or even complete outages, affecting the overall reliability of the electrical supply. Fourthly, insulation failure and arc flash mitigation is another key benefit. Ground fault protection plays a vital role in quickly detecting and clearing ground faults. This rapid clearing action reduces the likelihood of insulation failure, which can escalate into more severe incidents, such as arc flashes. Arc flashes are extremely dangerous events that can cause severe burns and other injuries. Fifthly, improved power quality is observed. By promptly removing ground fault currents, ground fault protection contributes to maintaining a cleaner power supply. Ground fault currents can introduce voltage distortion and other power quality issues that can negatively impact the performance of sensitive electronic equipment. Sixthly, adherence to code compliance is mandatory. Article 230.95 of the National Electrical Code, or NEC, mandates ground fault protection for grounded Wi services rated 1000 amps or more. This requirement serves as a fundamental safety measure, safeguarding the electrical system, connected equipment, and the personnel who interact with it. Ground fault protection can be implemented using various methods. These methods include ground fault circuit interrupters, often abbreviated as GFCIs, ground fault relays, and other approved devices specifically designed to detect ground fault currents and interrupt the circuit in a timely manner. These devices are engineered to sense even small imbalances in current, indicating a ground fault condition. When a ground fault is detected, the protective device rapidly trips, interrupting the flow of electricity and minimizing the potential for damage or injury. The specific type of ground fault protection employed may vary depending on the specific application, the characteristics of the electrical system, and the applicable codes and standards. However, the underlying principle remains consistent to provide a reliable and effective means of mitigating the risks associated with ground faults in high amperage grounded Wi services. Understanding the rationale behind ground fault protection and its proper implementation is essential for ensuring electrical safety and maintaining a reliable power supply. The NEC provides detailed guidelines and requirements for ground fault protection systems, which should be carefully consulted and followed.